Okay, so how to calculate mole fraction. So to get a mole fraction, which you usually give the symbol X and then a subscript, whatever substance it is, you want the number of moles of that substance divided by the total number of moles. So essentially, it's a fraction out of the total number of moles in your mixture, which might be two things, or it could be more, right? Could have multiple solutes in one solution. So it's basically expressing like a fractional percentage out of the total by mole. So the great thing about mole fractions, it does allow you to very quickly identify like what is the solvent, what is the solute, because remember the solute is the smaller mole fraction amount by moles out of the total, and then the solvent will be whichever has the highest mole fraction. So in this case, we're asked for the mole fraction of water. We are still going to have to calculate the number of moles of water we have and the number of moles of acetic acid we have, because we need to calculate the total number of moles in the solution. So first of all, the molar mass of water, I'm going to get from taking 2 times hydrogen molar mass, 1.079, plus oxygen 15.909, so that gives me 18.0148 grams per mole. And then we're going to do the same for my acetic acid. So my molar mass of my HCH3CO2 is going to be, well, we've got 2 carbons, so 12.011, and we've got 4 total hydrogens, 1.0079. Of course, use the ALEKS data tab. I can't see it from my end, so they may have different sig figs, etc. And then we've got 2 oxygens, 15.999. You should get about 60 point, hang on, I didn't write an equals there, 60.0516 grams per mole for your acetic acid. So let's start with our number of moles of my water. So that is going to be the 46 grams. Use the molar mass as a conversion factor. So for every 1 mole of water, that weighs 18.0148 grams. So that's going to give me, I'm going to round it to 5.535 moles. Okay, that's enough because we're only giving our answers to 2 sig figs. So I'm not going to get too excited with leaving a lot of decimal places there. Okay, so my number of moles of my acetic acid. Oh, hang on, I'm getting lazy with my shift key here. So we had 89 grams of acetic acid. So 1 mole HCH3CO2 weighs precisely, according to moi, 60.0516 grams. So press equals on my calculator, around 1.4821 moles. That is going to be fine. Okay, so far so good. So Gen Chem 1, right? So the new thing that we have learned for calculating mole fraction then is we need to calculate the total number of moles in the mixture. So my total number of moles is going to be my number of moles of H2O plus my number of moles of, in this case, CH3, sorry, H, CH3CO2. So that is going to be the 2.5535 plus the 1.4821. So that gives me a total of 4.0356 moles total. So we were only asked about the mole fraction of water. So my mole fraction of water is going to be my number of moles of water divided by total number of moles in the whole shebang, in the whole solution. So that is going to be 2.5535, and the whole thing is going to be unitless. The moles are going to cancel out, so 4.05356. So that is going to come out to be, to 2 sig figs, 0.37, okay? So it's kind of like a decimalized percentage, right? That's not 0.37 at all, it's 0.63. Thinking ahead, right? 0.63. So about 63% water in terms of the moles. So that allows us to now say with great confidence that water is the solvent and the acetic acid is the solute. Just for completeness, you could also work out the mole fraction of the acetic acid, because why wouldn't you, for extra practice? So then you would take the number of moles of your acetic acid Now I've got my shift key stuck. Oh dear. So that'd be again under the total number of moles. And that should, if your math brain is telling you it's got to be 0.37, you're correct, right? Because it's going to be whatever else is left out of 100%, right? So that would be the 1.4821 moles divided by, oh, that's gone wrong. Oh no! Oh, I'm just going to draw the line now. Oh dear. Computers don't like me today, clearly. Divided by the total number of moles, which is 4.0356. That is going to give me, where's my text box gone? That is going to give me 0.37. So the mole fractions should always add up to 1 altogether, right? It's like a decimalized percent, or you can convert them to percentages by times it by 100. So that'd be 63% water, 37% acetic acid, however you like to think of it. The important step is making sure you calculate your total number of moles of every component in the mixture, because that is what you're going to need to divide by to work out your mole fraction of one particular component.